already be adjacent to theta?
Is what?
Be adjacent to theta,
Indeed,
with L being the hypotenuse?
yes. Therefore,
You could solve for the opposite, but I'm not sure if that was better.
yeah, not needed.
Okay.
If I have the adjacent length and I have the hypotenuse, what can I do with that? Did it there, done it many times over the past month. All right, suppose instead I have a triangle with a hypotenuse of L and an angle theta here. What is this length of this side?
L cosine theta.
Yes. R is just L cosine theta. Or the cosine of an angle is equal to the adjacent of the hypotenuse. Over here, we can substitute in for R. So I have tension is equal to, times cosine of theta is equal to M1 omega squared times L cosine theta. Cosine theta conveniently cancels out. And so now I have, if that thing is behaving the way it should, the tension is equal to the swinging mass times omega squared times whatever length that is. If you notice in this apparatus here, there's that piece of tape hanging down below it. The point of that tape was so that you can keep the length constant. So if you have it so that the tape is sort of a constant distance below this, we get it swinging. And then all I have to do is keep an eye on the tape there to make sure it stays basically the same distance from the bottom the entire time. And apparently it did not. If I know that that distance is constant, then I know that that length is constant. So let's actually use a number here. Let's say that the length is 0.7 meters. I don't need to know what the radius of the circle is because R is going to go away. I don't need to know what the angle is because the angle is going to go away. Let's actually solve for mass 2. What does mass 2 need to be? If this thing is spinning around and let's say it's doing it in 1.1 seconds. So the period as it swings around is 1.1 seconds. So omega is, if it takes 1.1 seconds to go around, going around once is 2 pi radians. So that's over 1.1. And what is the angular speed then?
So 5.7119.
5.7119. Good thing. All right. Units?
So without being radians then?
More than just radians. The 2 pi is in radians.
Per second.
Yeah, radians per second. So I know what omega is now, length I gave you over there, mass 1, oh, I didn't give you mass 1. So let's make this 0.04 kilograms, so 40 grams. Not completely unrealistic, our biggest one I think is bigger than that. The smallest ones are somewhere around 10 grams. So I have a tension equal to 0.04 kilograms times omega, 5.7119 radians per second, squared times my length, which is 0.7 meters, and I can find my tension. Estimating somewhere around 0.8. Anyone?
I got 0.9135.
Anyone else?
Yes.
Okay. Units?
Meters. Tension. I'm talking out loud, I'm sorry.
Okay. Oh. Just want to make sure I wasn't missing something they were saying to everyone. If nothing else, you can just look at the units that we multiplied together and just string that together appropriately. All right, let's piece it together. What did we multiply together, unit-wise?
Kilograms rads per second and meters.
Don't forget the square.
Squared. Yep, rad.
So kilograms,
Yep.
radians, squared, meters per second squared. Now the radian, if we go back to our equation, this one right here, S is the arc length and R is the radius. These are both units of length. So if R is 2 meters and S is 4 meters, plug it into that equation to figure out what angle that would be. So I basically have something of radius 2, and then I take 2 of those. So that's 4 meters, this is 2 meters. Trying to figure out what that angle is. Well, I plug into that formula, I get 4 meters is equal to 2 meters times theta. So what is theta? Go on.
2.
Thank you. Why are people so quiet about that? I'm not getting the silence. To what?
Radian.
Yeah, but if I just look at the units here, I'm doing meters divided by meters. Radians are unitless. You put them in when you need to communicate them, you take them out when it becomes inconvenient. So this radian squared here, we can just leave off. So this is 0.9135 kilogram meters per second squared, which is also known as, yes, it better be newtons because we're finding a force here. I would expect it to be newtons. So this is 0.9135 newtons. Now ultimately I wanted to find the mass here, but that's my tension, which is, well, I got something right over here. I got my equation from mass 2 down there. So this is 0.9135 newtons is equal to my mass 2 times 9.8 meters per second squared. So mass 2 equals
So that would be 0.0932.
0.0932 units.
Kilogram.
Yep. So 93 gram mass. Questions here? If people just finish writing down, and then we'll talk about the other classic motion problem, and then at least we'll set it up. It's the exact same process. What we're about to go through is the exact same thing that we've gone through before. If I've got a track here, overhead view, and I have a car going around the track at some speed v, we'll make the track frictionless, and it is banked. Bank track means that if I'm looking at it from the point of view, if I'm looking behind the car at this point in the track has some angle theta here. That's supposed to be a car, the rear end view. This is the rear view. And the question is, at least to start out with, is what is the angle that is necessary for this car to maintain, to be able to go around? Now, because I made the track frictionless, if it goes a little bit above this, the car will start sliding to the outer part. If it goes a little bit below that speed, it'll start sliding to the inner part. Thank goodness for friction. It saves lives. Force diagram. The force diagram looks a whole lot like box on ramp. I have weight acting down. I have normal force acting this way. The difference comes in the direction of acceleration. If it were box on ramp, the acceleration would be down the ramp. What is the direction of acceleration now?
Is it gonna be up the ramp?
I hope not.
This will be towards the center.
And which way is the center?
Oh.
Left.
Yeah, at that point, the acceleration is that way. It is not down the ramp. If you're saying the acceleration is down the ramp for circular motion, then what you're saying is that that car is traveling in a circle like this, instead of a circle like this. So, box on ramp, we're breaking weight up, we have to break normal force up now. So I know that that's what I'm breaking up right there. I know this angle here is theta, and so this angle right here is theta. Normal force is perpendicular to the ramp, that's normal. So this angle right here is the complement. There's my triangle right there that I'm breaking up. This angle up here is theta, because that's the complement of theta. And so my horizontal piece is y sine of theta. My vertical piece, y cosine of theta. And then tweak down. All right, I'm gonna grab the test. Then talk about test corrections. Test corrections. On separate paper. Yeah, don't do test corrections on the test itself. I don't want to have to differentiate between what you did the first time and what you did the second time. And an original test, or a copy of it, with the corrections. You are trying to convince me that you understand. Just putting an answer down will get you nothing. I need to know how you came upon that. You're trying to convince me. If two people are working together, and there's nothing wrong with that, there's no restrictions on with whom you can work on this, but if two people work together and they hand in identical answers, I'm not playing the game of which one of you knew it and which one of you copied it. Use your own words or language, or, again, you're trying to convince me that you understand. Not in red ink. Flashing back to that one student. Did it in red ink on the original test, which was also done in red ink. If I was never sure about what he did the first time versus the second time, he did not get the benefit of the doubt. All right, so original score, best possible new score. On a 4.0 scale, if you got an A on the test, you can bring it up to an A+. If you failed the test, straight up, plain old F, not F+ or anything like that. If you have an F on the test, you can bring it up to a C. And then that's basically sets up the linear relationship. So halfway in between, if you got a C on the test, you can bring that up to, halfway between those, which was a 3.15. Typically. Very few people get full credit, and that's just because, the people up here, they have an A already, so they generally don't put in the effort to fix the tiny little stuff that they messed up. And people down here have so many mistakes that they've made that you know, it takes time commitment to finish getting it off, finish getting them. So it is not it's not a foregone conclusion, but it does take effort in order to get the maximum number of points. If I'm industrious enough, I'll post the answer, so you'll at least know what your target is. So, another thing, if you're doing test corrections, please make sure that at least the answer that you end up with is the correct answer. I've even posted answers, had students hand in ones with a different answer. It makes grading it a lot easier. But my preference is, you will dazzle me. I want tears of joy streaming down my face. For the sake of the example here, let's say that it was 130 points total on the test, and you had 60 points. And that was, because the math is easy, that was a C. That means you missed 70. So you get credit for those 70 points that you missed. Let's say that you convince me you understand most of it, you got 50 out of the 70 points that possible. That times what you possibly could have gotten in terms of your score, you could have gained, that's a plus 1.15. So you have your original grade plus the fraction of what you could have gotten, and then that comes out to some number. That number is what will go into the grade book. I don't round off after that. You know, a C is a C, regardless of what the raw score is. However, this score over here will be, you know, potentially it's a 3.02, and it'll go in as a 3.02. At this point, with this grade taken into account, none of you can do better than an A in this class, but it has eliminated so that none of you can get worse than an F. That's how much it has narrowed down your grades. So somewhere from A to F inclusive. And you have it, you can go. If you have questions that are burning about this that you want to ask, that's fine, but my preference is that you ask the questions about what I'm handing back to you, not today, just to let it sort of sink in a little bit before we talk. However, some people just need to know something at that moment. Yeah, I'll glad to address that. And also, surprisingly, few of you decided to show your work on a number of problems. Please, show your work.